All right, guys. Well, welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Hoping everybody's okay. We're on warm-up number 118, so go ahead and copy that. Number 1 reads, rewrite each expression. Part A is 3 to the negative 4th power. B is 1/4 to the negative 3rd power. And C is 3 times square root of 3. Number 2, it says, if x to the 3rd times x to the 5th equals x to the 3rd plus 5 power, which is x to the 8th, then rewrite 2 to the x minus 3 power. Number 3, use the binomial theorem to expand parentheses x plus 3 close parentheses to the 4th power. And number 4, given the sequence, write the explicit rule and use a rule to identify the number of terms in the sequence. Sequence given is 1, 2, 4, 8, ... 128. Go ahead and copy that. I'll give you some time if you want to pause the video right now so you can have time to do that on your own. Copy and go. All right, so by now you should be done with the warm-up after you paused it. So let me go over the warm-up. I'm going to start with number 1. Let me make some space here. All right. So number 1A says rewrite. So I'm going to rewrite this. Can we leave this with a negative exponent? No. So this is written 1 over 3 to the 4th. Is that correct? Yeah, because any negative exponent goes to the denominator. However, can we leave it like that? Yeah, but we can simplify more. So this is 1 over 81. Where did I get the 81? Because this is 3 to the 4th power, which means 3 times 3 times 3 times 3. There it is. All right. Go to number 1B. 1B, same thing. This has an exponent of negative 3, and we have a 1/4 inside parentheses. So the numerator has an exponent of 1, the denominator same thing. Distribute. So this becomes 1 to the negative 3rd power over 4 to the negative 3rd power. But we can't leave the negative 1, the 1 to the negative 3rd power, so we send that to the denominator, and it's a positive 3. But in the denominator, we have 4 to the negative 3. So now we send it to the numerator to make it into a positive. So now, can we simplify that? Yes, this is 4 to the 3rd is 4 times 4 times 4. 4 times 4 is 16. Times 4, that's 64. 1 times 1 times 1 is 1. So this is 64. Let me put this up there. Okay, let's go to this one. This is going to be an interesting one. So for this one, let me make some space. All right, so first of all, we need to rewrite this. You're saying, but it's already simplified, Mr. Q. I know, but they want us to rewrite it, I guess, to the original way, or the original form. So this 3 came out of the radical. And what do we know about radicals? That is square roots. So what is the inverse of a square root? Squared. So what is 3 squared? 9. So this was square root of 3 times 9. Is that correct? Yes? All right. But for the purpose of what we're going to need for today, I'm going to leave this in the same form as this one, base 3. So this is written square root of, we got 3 times, how can we write this with the same base? 3 to the what? To the 2nd power. Okay, so can we combine these now that they have the same base? Yes. What is the invisible exponent here? 1. So this is square root of 3, because they're the same base. And what happens to the exponents if we're multiplying? They add. So that's 3 to the 3rd. Okay, so now that we have that, we still haven't finished simplifying. Let's see. 3 to the 3rd. We have a radical, square root. What's another form of writing radical or square roots? Yeah, it's a power. What kind of power? Exactly, 1/2. Who remembers that? 1/2. All right, so if we distribute the 1/2 to here, what do we get? 3 to the 3/2. There it is. Let's do another one just for the sake of practicing. Let's do example 1Q and write, let's see, 5 to the times square root of 5. All right, so what do we say? The 5 came from the inside of here, so this is square root of 5 times, and what was 5 inside of the radical? What is the inverse of a square root? Squared, so this is 5, that's 25. Is that correct? Yes, but we said let's rewrite these with the same base. So that means this is 5, and the 25, how can we write that? Yeah, 5 to the second. Now we can combine. This is to the exponent of 1. They're the same base, square root of same base of 5. What happens to the exponents that we're multiplying? We add, that's 5 to the third. All right, we're almost there. So we have 5 to the third. And how do we write the radical and exponent? Yeah, to the 1/2. So we distribute that, and that gives us 5 to the 3/2. All right. All right, let's go to number 2. Number 2 is x to the third times x to the fifth is the same as x to the 3 plus 5, which is x to the 8th. Then we write 2 to the x to the negative 3. So we can rewrite this as 2 to the x times 2 to the negative 3. Pretty much what we've been practicing right now, what we did earlier with that one problem, right? So let's see. So let's rewrite this. 2 to the x stays the same. However, doesn't this have a negative exponent? Yes, so where do we send it? To the denominator. And it's 2 to the third power. Can we simplify 2 to the third power? Yeah. So this becomes 2 to the x over 8. All right. Go to using the binomial theorem to expand. So let me make some room here. So the binomial theorem, you guys remember that we need the Pascal triangle, right? So we start our Pascal triangle on the over here on the side. So it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And when do we stop, Mr. Q? We stop whenever we see, because this one they tell us to raise it to the 4th power. Whenever our pattern shows us that number. Right now we don't see it yet. Let's look at the next number. 1, 4, 6, 4, 1. Do you see the number 4 now? Yeah, it's right there. So we stop here. These are going to be our coefficients of our expanded form of that binomial. So I write 1, leave a little space, plus 4, leave a little space, plus 6, space, plus 4, space, plus 1. My goodness. Let me move this over to the right a little bit more. All right. Now that we have that, let's see. Let's see if you remember. We start with this first term, that is x to the 4th. And the second term is times 3 to the 0 exponent. You guys remember this? Yeah, remember the exponents of those two terms, or the two factors, need to always add up to 4. But from this point forward, the first factor descends the exponent, and this one ascends. So for this one, we write x to the 3rd and 3 to the what? to the first power. Notice that this one went down and this one went up, but they still add to 4. What would be the next one? X to the second and 3 to the second. They still add to 4. What is the next one? X to the first and 3 to the third. And what is our last one? X to the 0 and 3 to the 4th. All right, now that we wrote it, we just need to simplify it. Let's see. X to the 4th. 3 to the 0 is 1. What is 1 times 1? 1. Do we need to write it? No. Plus. What is 3 to the 1st? 3. We multiply that times that. What is 3 times 4? 12. X to the 3rd. Plus. What is 3 to the 2nd? 9. Multiply that times 6. What is 9 times 6? 54. Bring down the x to the 2nd. Plus. What is 3 times 3? 3 to the 3rd, sorry. 3 to the 3rd is 27. Multiply 27 times 4. 27 times 4 is, let's see, 80 and 28. That's 108. X to the 1st. Plus 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3, which is 81. Multiply that times 1, so that's 81. And x to the 0 is 1, so do we need to write it? No. We are set. Yeah? Is it coming back? All right, good. All right, so let's move on. Our home plate for tonight is page 756, all only. Page 756, all only. And your near pot code is RISUO. RISUO, and that's to submit your home play, your notes. And remember, every slide that has the toolbar at the bottom on Nearpod, make sure you lock your toolbar, take pictures of your work, and submit. Now, when you log in, remember, always start with your period number. So if you're in period 1, you type in 1, leave a little space, and then your name. Michael Jordan, and so on and so forth. All right. Now, some of you, I've gotten only a couple of you that send me emails saying that you were struggling with submitting work. Then take pictures and submit via email. You guys have my email. All right. So, move on. Our objective for today: I can define and evaluate logarithmic functions. I can define and evaluate logarithmic functions. Yes, so today we're moving on, and everything we've done, like I said, everything plays a role. Every little thing that we practice, even on the warm-ups, plays a role on to getting us to where we need to be. And today we're going to be in what? Logarithmic functions. All right, so logarithmic functions, you guys probably heard of it before. Some people call them logs, and that's fine. We'll leave it for right now as is. So what are logarithmic functions? Get your fair model ready. I'll give you some time. Pause your video in the meantime. All right, so what are logarithmic functions? Well, logarithmic functions actually come from trying to answer the question in exponential functions. That's why the definition for logarithmic functions is the inverse of an exponential function. The inverse of an exponential function, where b has to be greater than 0, but it cannot be equal to 1. And remember that b we consider the base. So what are the forms? The forms that we're going to look at look like this. F inverse of x equals log b, or subscript b, of x, or x equals log subscript b a, or log b of a. Copy that. Pause the video if you need more time. All right. So for right now, I just want you to see the form that it looks like, and that you understand that it's the inverse of a what? Of an exponential function. We've been working with exponential functions before we went to Easter break, so we're coming back and we're going to be referring back to that. But these are the forms that we want to understand, that these are logs. And what is one thing that you notice that it says what? Log. That is correct. So here are more examples. F inverse of x equals log 5x, and 3 equals log 464. Copy those. Once again, if you need to pause the video, pause it. All right, non-examples. 5 times 2 to the x minus 3 power, and at the end plus 4, and f of x equals x squared. So by looking at these, look at the examples, look at the non-examples. What do you guys notice is the major difference between logs and not logs, or logarithmic functions? All right, yeah, that they say what? Log. You can't get away from that. So yeah, it says log, and what else? Dealing with exponents and so on and so forth. So do a hashtag on here. So we can do hashtag log in the function. Hashtag not exponential function. So just write some hashtags as what you see that a logarithmic function looks like. That's fine. And I'm going to elaborate more on the logarithmic. All right? Okay. And yeah, B, I put also function. It is a function. Yeah, it is a function. The base is B. Yeah, base is B. Base is B. To solve for an exponent. So move on. Now, to get started, I'm going to go with the definition of logarithm. Logarithm. What is a logarithm? Well, according to the definition, it says the exponent that a base is raised to find a given number. The exponent the base is raised to find a given number. However, I wrote it in a question format because I think it's better to understand in that way. So I wrote, to what exponent does a base need to be raised to in order to get the given number? To what exponent does a base need to be raised to in order to get the given number? All right? So let me show you the form we're going to be using for today. The form is x equals log b of a. So copy this. I'll pause the video really quick. All right. So with that said, can we identify the components of what this is our logarithmic function. So each part plays a role. So let's see. X is our what? Exponent. What is b? The base. And what is a? A given number. And once again, if you want to point arrows, make sure you have your colored pens. So given number is a. Base is b. And of course, the exponent is here in this part. All right. So with that said, let's continue. So what if I gave you this table? So check this out. On the left side, I'm going to write the logarithmic function. There it is. But now, in order for us to get to where I want us to be, we need to rewrite this and the inverse of this. The inverse, we said it was a what? The exponential function. So check this out. The exponential form of this logarithmic function is as follows. What is our base according to this? B. What is the exponent? X. And what is the number that we need to find? A. So that means this is written base of b to the x power equals to a. Now, let's see if that concurs with the definition for logarithmic. I wrote in a question mark. To what exponent does a base need to be raised to in order to get the given number? What was the given number? A. Yeah, that makes sense. All right, so now let me use numbers so you guys can see it translated into numbers. So let's say I gave you this one. X equals log of 2, 64. So what is our base? 2. What is the exponent? X. And what is the number that we need to find? 64. So if we were to rewrite this, it would be base 2 exponent of x equals to 64. So far, so good? All right, let's see. You write this one. X equals log of 5 of 125. Let's see if you can rewrite that in an exponential function form. All right. What is our base? 5. What is the exponent? X. And what is the number that we're going to find? 125. So therefore, this is base 5 exponent of x equals to 125. All right. So let's get some more practice with this. Example 1. Write this down. Example 1 reads, rewrite the log as an exponential. Rewrite the log as an exponential. There's our log. X equals log 4 to 16. So now, I left over here on the top right what it looks like, because if you notice now I wrote it all in black, but so that in case you need to refer to it, there it is. However, what is our base according to this log? 4. And what is the exponent? X. And it should equal to what? All right. So therefore, our base is 4. Our exponent is x. And the number that we need to find is, or the given number is 16. Piece of cake? All right. You do this next one. Example 1Q. X equals log 3 of 81. You want to pause the video, that's fine. If not, go ahead. Let's rewrite this. What is our base? 3, exponent, x, and the given number, 81. So this is log form, and this is exponential form. Okay. Let's do another one. Example 1 super Q. X equals log 2 and to the 1/4. Let's see if you can rewrite that. Once again, you can pause the video or just keep going. So let's see, what's our base? 2 exponent x, and what is the given number? 1/4. There it is. Pretty good? Yeah, Mr. Q, these are a piece of cake. All right. All right. How about we go the other way around? Example number 2, it says rewrite the exponential function as a log. Exponential function as a log. All right, let me help you with this one first. What stays over here on this side? The exponent. Okay, the exponent. And then we write what? Log. And what is our base? 2. And what is the given number? 32. Very simple? Yeah, right? All right, do this next one by yourself. Example 2Q. If you want to pause the video at this time, pause it if you need more time. There it is, example 2Q, and it says again, rewrite the exponential function as a log, and the exponential function given is 4 to the x power equal to 64. Pause the video if you need more time to write it down. I'm going to continue now without the colors. I'm just going to continue with black. First of all, what stays on this side? Very good, the exponent. Okay. And then we write what? Log. And what is our base? Base is 4. And what is the given number? 64. All right, let's do another one. Example 2 super Q. And it reads, rewrite the exponential function as a log. And the exponential function given is 2 to the x power equal to 1/8. Pause it if you need to and do that one by yourself. Copy and go. All right. So we write x equals log base 2 and 1/8 is our given number. All right, so I think we got it. Now, I just wanted to make sure we got enough practice looking at it both ways. All right, now check this out. So now that we know what it looks like, let's solve for x. This one says, example number 3, solve for x. And the equation given is x equals log of 2 to the 1/8. All right, so how can we solve, Mr. Q? Well, whenever they give you to solve a logarithmic function, such as this one, the first step, and you can write that down, step 1, you need to rewrite it as an exponential function. So, step 1, rewrite. So, how can we rewrite this? Yeah, so what is our base? 2. What is the exponent? X. And what is the given number? 1/8. All right. Step 2. Both sides same base. Both sides need to have the same base. Now let's see. This one is base 2. Does this one have base 2? No, it's an 8. Can we rewrite 8 in a base 2 format? Yeah. So we remember we can use the factor tree. Can 8 be divided by 2? Yeah, that's 4. Can 4 be divided by 2? Yeah, that's 2 times 2. So that means this can be written as 1 over 2 to the 3rd power. So at this time, I'm going to rewrite the whole equation to 2 to the x equals to 1 to the 2 to the 3rd power. 1 over 2 to the 3rd power. All right. So we're still not completely there. We need to have this one to base 2, and right now it's in fraction form. So to make this not in fraction form, we need to send this 2 to the numerator. Is that correct? So if we do that, that means, check this out, that means that this becomes 2, and if it's a positive 3, we send it to the numerator, it becomes a what? A negative. And all that equals to 2 to the x. Now, do we have both sides to the same base? Yes. And step 3, last step. Set the exponents equal to each other and solve. All right, so that means we focus where? Right here. All right, so then that means we do x equals negative 3, and we already solved. So therefore, what is our solution? X to the negative 3. So for x equals log of 2 to the 8th, this is x equals negative 3. Or in other words, the base 2 raised to the x exponent that gives us 1/8, the x is what? Negative 3. And we can substitute that in there and it should give us the same answer. All right? And I just remember we didn't do the last problem on the warm-up. That's fine. It's practice from what we did last time, and it's basically what we're doing right now. All right? So copy that. So let's see the process again. Number 1, we need to rewrite it as an exponential expression, an equation or function. Make sure both sides have the same base, and then at the end, set each of the exponents equal to each other and solve. All right, let's see, you do one. Example 3Q. Solve for x. We have x equals log 3, 1 over 81. Okay, step 1, rewrite it. What is our base? 3 to the x power, and all that equals to 1 over 81. All right. However, the 81 needs to be the same base as that. The base given is 3. So 81 divided by 3 is 27. 27 divided by 3 is 9. And 9 divided by 3 is 3. So how many 3's do we see? 3. So that means 4, my bad. 4. So that means 1 over 3 to the 4th. So let me rewrite this. So we get 3 to the x power equals to 1 over 3 to the 4th. Do they have the same base already? Almost. The only thing, this one's in the denominator. Where do we need to send it? That is correct, to the numerator. So this becomes 3 to the what? It was a positive 4. It becomes what? Negative 4 equals 2. And this is 3 to the x. And last step, write the exponents equal to each other and solve. There's nothing to solve because it's already there. So therefore, for x equals log 3 and to 181, and that is x, solution is x equals to negative 4. Sorry, negative 4. They're like, I get it, Mr. Q, we've been doing this. Yeah, we've been doing this on the warm-ups. So, let's see you do one by yourself. Here it goes. Example 3 super cube says, solve for x. X equals log 4 of 64. Pause it if you want, so you can have some more time, and then go at it. Copy and go. All right, so let's rewrite it in an exponential. This is 4 to the x equals 64. All right, so what base does this one have? 4. So that means that step 2, same basis. So can we divide 4 by 64? Yes, that is 16. How about 16 again by 4? Yeah, 4 and 4. Okay. Therefore, see what I did there? Anyway. 4 to the 3rd power. So let's rewrite it. Yeah, 64 can be rewritten as 4 to the 3rd. So this is 4 to the 3rd, and all that equals to 4 to the x. And now the exponents, we set them equal to each other, so x equals to 3. So that means the solution for this is x equals 3. And have you got that? Bam! All right. Pretty simple. All right. Let's crank it up a notch. And this is our last example. And it says evaluate the logarithmic function. And you're like, oh, snap, Mr. Q. I know. It looks a little bit different, but the process is fairly the same. There's just one little minor thing that we need to do when evaluating. Evaluating, which means we substitute the value given. So it says example 4, evaluate the logarithmic function f of x equals log 7x for f of 49, comma, also for f of 1 over 343, comma, and f of 7 square root of 7. All right, so I'm going to start with this one first. So I'm going to write f parentheses log 7 and then parentheses for the x. So I'm going to start with this one first. What value are we going to substitute? 49. 49. So what do we know? I'm going to rewrite this side first. Log 7 of 49. Does this look familiar? Yeah. This side doesn't look familiar. So this is the only difference from what we did earlier to right now. When we evaluate, we substitute the values for x. There it is. So now, this side, we no longer write f of 49, and we no longer write x anymore because we would have to substitute again over here a number. What we would write here, we're going to change this. This is the only step that's a little bit different. We change this to the variable y. Y, Mr. Q. So like that, we are able to evaluate what they're asking us to do. But do we know how to rewrite this now? Yeah. How do we rewrite this? Because we need to solve for y. So how do we do that? What is our base? 7 exponent y, and that should give us what? 49. Does this look familiar? Yeah. Oh, I get it, Mr. Q. Yeah, the only thing that's going to be different, like I said, is substituting that value first. There it is. And rewriting it, and now in terms of, instead of f of 49 or f of whatever, you change this side to y. All right, and the rest is the same. Don't we need the same base? Yeah, let's see. 49 divided by 7 is 7. All right, so this can be rewritten as what? 7 to the what? Second power. So I'm going to rewrite the whole equation. 7 to the y power equals 7 to the second power. So all we have to do is what? Write the exponent of an equation. So y equals 2. Pretty simple. Yeah, copy that. Pause it if you want, and I'm going to get started with the next one. What is the next one? F of parentheses equals log 7 parentheses for the x, right? So basically the parentheses I just leave x for parentheses or parentheses for x. So the next value that I'm going to substitute is what? 1 over 343. 1 over 343. So let me rewrite this. What does that mean? Now I'm going to change this side to what variable now? Y log 7. And what number are they asking us to find out? 100 and over 343. Okay. So we need to change to exponential form. So this is what? 7, base 7, to the y power equals to what? 1 over 343. All right. And what is the next step? We need same basis. So this has to be to base 7. Let's see. 343 divided by 7, that's 49. 49 divided by 7 is 7. So this could be written as 7 to the third power, like this, underneath 1. So let me rewrite that. So we get 7 to the y power equals to 1 over 7 to the third power. Do they have the same base now? Almost, but this one's in the denominator. It needs to be in the numerator. So that means I'm going to move this one up to the numerator. That changes the exponent to what? Negative 3. Yeah. 7 to the negative 3 equals to 7 to the y. And now they have the same base. We just set the exponents equal to each other. So y equals negative 3. Piece of cake? Yes, Mr. Q. All right, good. All right, so we'll pause the video so you can copy that unless you're already ahead of me. And I'm going to get started with the last one. The last one, I do f of parentheses equals log 7 parentheses. But now I'm going to substitute what? 7 square root of 7. 7 square root of 7. All right, so what do we know? That this side turns into what variable? Y. Left side turns into y. This one is log 7, base 7, and they give us the number 7 square root of 7. All right, so let's rewrite that in the exponential format. So what is our base? 7 to the y power equals to 7 square root of 7. Now, they're not same base because this one has a radical. So we need to rewrite this one. So that means the 7 came from inside, didn't it? So I'm going to go this way so you guys can see it. You're like, oh, that's why we practice on the warm-up. I know, right? Let's go. So let's see. So this is square root of 7 times. This one, before it was 7, it was in here, was 49. Is that correct? So let me write it out, 49. However, they need to be the same base. So this is square root of 7 times what? 7 to the second power. And that means this is 7 to the first. I'm sorry. This is 7 to the first. So if we have the same base, so we have square root of 7 to the third. However, 7 to the third we can rewrite this. Let's see. Get my eraser. This one can be rewritten as 7 to the third power, and all that to the square root is what kind of power? 1/2. So this is 7 to the 3/2. Woo, that was kind of long, but I mean, we practiced that earlier, and we've been doing this already for a while, but I'm just bringing it back. So now this is this side, and the other side is like this. Let's rewrite it. So we end up with 7 to the y power equals to 7 to the 3/2. So therefore, last step, set the exponents equal to each other. So y equals to the 3/2. And basically that's the home plate, guys. The home plate, they're going to ask you to evaluate using 3 different formats. The format first, just a number. Then from there, a fraction of a number. And then a radical form. There we are. All right, guys. Well, that's our lesson for today. So what did we do? Today we define and evaluated logarithmic functions. All right. So once again, our home plate for tonight is page 756, all only, and your Nearpod code is RISUO, so you can submit your work and your notes. And just remember, guys, if you're not moving forward, then you're already behind. Bam, let's go. Once again, I hope everybody's doing well. If anything, send me an email. I'll talk to you guys and hopefully go on Thursday for a live. So see you guys during the live one this Thursday. All right? Peace out. Bam. Bye.